Natural physics is a concept I developed that explains in down-to-earth scenarios how the principles of physics could have come about from observing nature. Each episode begins with a scenario followed by an example to illustrate the application of these principles in futuristic research at the frontiers of science, such as my astrophysics research, and then concludes with an exploration of how these same principles could have very well been used by ancient cultures and civilizations. Mathematics is naturally encountered and incorporated as the exciting and fun tool of science that it is. Science is the window into our amazing world of nature, and mathematics is the tool to open that window. Natural physics encompasses current, futuristic, and ancient physics, and ties them together by the principles of physics that are common threads running throughout each. Greetings, I'm Leroy Larry, and welcome to our Natural Physics Variety Show, live from Costa Rica. Joining us again today to further discuss his book, Northern Constellation, Canada's Mission to Titan, is author August Wogemuth. August, here is illustrated the rockets that are going to take your robotic Hamlets, Peanuts, and Pete's from Earth to Titan, the largest moon of Saturn. All right, so now we were talking about the payload that you're looking at. The payload that the two rockets that are going to take the Hamlets up, that they're going to be able to handle. You're looking at the payload that the two rockets that are going to take the Peanuts up are going to be able to handle. And then we're looking at the payload that the one rocket that's going to take the Pete's up is going to be able to handle. All right. All right. So, okay, remember the Saturn V, which was at its time the most powerful rocket ever built. Okay, and it took the Apollo astronauts, all the Apollo missions. The Saturn V rocket was what got them off the Earth, away from the Earth's gravity and into outer space, and gave them enough energy and momentum to make it to the moon, which I believe took 3 days. Okay, so amazing rocket, the Saturn V. And you know what, August? I know people that live in Florida where Cape Kennedy is. So again, the Saturn V rocket, it could handle, according to this information, it had the largest payload capacity of 311,152 pounds, which equates to 141,136 kilograms. And wow. August, that included the unburned propellant, which is the fuel. Okay, remember last show I talked about when you're talking about escaping the Earth's gravity and the weight involved, you're talking about not only the payload, but the fuel, everything, right? Gravity, the force of gravity, August, acts on everything that has a physical amount to it. From the smallest, tiniest electron to the hugest black hole in the universe, gravity. Gravity is always there. So yes, the Saturn V rocket. And what I was going to say was, I know people, August, that live in Florida, not far from Cape Kennedy, Cape Canaveral. They grew up in the 60s and the 70s when the Apollo missions were going on. And they said, August, that when the Saturn V rocket took off, it felt like an earthquake. If you're at your house, if you're at your home
right? The ground is trembling and is shaking. That's how powerful the Saturn V rocket was. I mean, unbelievable power, August. Yeah, and actually, I read that now Cape Kennedy is kind of in the middle part of Florida, and the northern part of Florida. I remember reading that even people that lived in the northern part of Florida, they could feel little tremors in the ground when the Saturn, even though they were that far north, they could feel tremors in the ground from when the Saturn V rocket lifted off. So again, August, there's the power, the force that's required for the Saturn V rocket to not only escape the gravity of the Earth, but to also get the Apollo astronauts to the moon. Okay. And
Wow,
then,
that's cool.
yes, it is, isn't it? And then,
Uh-huh.
according to this, the Artemis rocket is now the most powerful rocket in the world. And it can carry a payload of 59,000 pounds to the moon. That's
Wow.
right. I mean, unbelievable power. Okay, now it says for the Artemis, it can carry 59,000. But Saturn V was 311,000, which is more. Okay. So I think what that must mean, August, is that the Artemis rocket is the most powerful rocket in the world right now. The
Yeah.
Saturn, the Saturn V is still the record holder. The Saturn V is still the most powerful rocket that was ever built, ever built. And the Artemis rocket is not as powerful as the Saturn V was, but right now in 2024, it is the most powerful rocket in the world. We're going to calculate the payload of the rockets that have to take your Hamlets, your Peanuts, and your Pete's from the Earth to Titan. Okay.
5,000. Sorry, I said
There,
something.
that's okay. That's okay. 5,000. All right. So the payload of the one rocket that's going to take 100 Hamlets up is equal to 50 times 100. 50
Yeah.
pounds. Yeah, 50 pounds that one Hamlet weighs times 100 Hamlets. So 5,000 pounds. So that's to say the second rocket that's going to take another 100 Hamlets up, the payload for that rocket is also going to have to be 5,000 pounds, just like the first rocket. Okay?
Yeah.
Okay. Now let's go to Peanut. If one peanut weighs 100 pounds, 100 peanuts will weigh 10,000. Is that what you said?
Yeah.
Excellent. So the payload of the one rocket that will take 100 peanuts up is 10,000 pounds. And the payload of the second rocket that will also take 100 peanuts up is also 10,000 pounds. Okay, excellent. We are rocking and rolling. Now, for the one rocket that's going to take up the 400 Pete's, let's calculate what the payload of that rocket is. So one Pete weighs how much, August?
Uh, 1 pound.
1 pound. So how much do you think 400 Pete's are going to weigh?
400.
There you go. 400 pounds. All right. So we got the payload for each of the 5 rockets that are going to take the Hamlets, the Peanuts, and the Pete's from Earth to Titan. The payload that those 5 rockets are going to have to each handle to get off the surface of the Earth to escape the force of gravity of the Earth, your 5 rockets have to provide a force that's more than that force of gravity that's trying to keep them on the surface of the Earth. So the force that your rockets are exerting against the force of gravity is equal to the mass of the hamlets, the 100 hamlets in one rocket, in each rocket, the 100 peanuts in each of the 2 rockets, and the 400 peats in the one rocket. Your rocket is going to have to exert a force on those that's equal to the mass of them times the rocket's acceleration to enable it to overcome the force of gravity. Okay?
Okay.
Okay. Do you have any questions about this at all, August?
No,
No.
it's
Okay.
cool how you can tell uh what the payload is by just calculating it.
Yeah. Yes. Now, this illustration shows one rocket. I see robots and I see food. Could you explain what's going on with this rocket?
So that one rocket is the Pete's robot.
Uh-huh.
Pete's rocket. So the bottom half of the capsule is food, and then the other part is where all of the 500 hamlets go. Like they're like the size of a boat, so they just go around the whole capsule, and then there's a couple shelves too. So the top part has all of the robots where all of the Pete's are going to go, and then the bottom part is the where the food for the astronaut goes. But there is also some batteries in there for the uh for the robots.
Okay. You have a very intricate mission because not only are your mission requirements dealing with human needs, but also robotic needs. Wow. Whoa, that's quite a mission there, August. That's quite the mission. Right here, I scrolled down. This is a picture of your launch site in Canada that's going to launch the 5 rockets to Titan, correct?
Yeah.
Canadian flag on the side, right on. Okay. Canada's mission to Titan. Excellent. Excellent. There's the submarine that's going to go below the methane oceans, right?
Yeah.
Right.
And then they took it all apart and then rebuilt it again.
There you go. Excellent, August. I'm so glad to hear that. You're truly a scientist and an engineer because you're having to combine concepts from physics with the engineering of building your rockets, your submarine. So again, as you said, you did that test. So remember the gravity, the buoyancy, how your submarine is going to float on Titan based on gravity is different than it's going to be on the Earth. So many things to take into account. All right, let's summarize. Hamlet can handle 1 ton of weight, and Hamlet weighs 50 pounds. Peanut can handle 14 pounds of weight, and Peanut weighs 70 pounds.
Yeah.
And Pete can handle 2 pounds, and Pete weighs about 1 pound.
Yeah.
All right. Those are some great statistics of the robots that are going to be preparing a year ahead of time for your astronauts to arrive at Titan. Wow, you see all the physics that came out of your book?
Yeah.
And there's still a lot more. I mean, just so many aspects of your mission is dependent upon physics. And then for engineering to come along and apply that physics to practical applications for your mission. So, all right. You have any questions at all about what we've talked about?
Nope.
No questions, August?
Nope.
Okay. All right, everybody. Tune in next summer solstice. Same fat time, same fat channel. All right. Bye, August.
Bye.
All right.
Thanks for class.
Thank you, August. Thank you as always. Bye-bye.
Bye.
Okay. All right.